My name is Joonas Bergius. I'm an engineering manager at DigitalOcean. And I'm going to be talking about underpinnings of a cloud. The idea of this talk is that we all use a lot of software to make our systems go. And a lot of this software is sort of when you are running on top of an existing cloud. Now, things are sometimes a little different when you are an actual cloud provider yourself. So I'm going to talk a little bit about the systems we have and sort of how we've put these things together and how we actually use some of the software that I'm sure all of you use also to make that happen. So without further ado, I should switch focus to the right app. There we go. Cool. So I want to kind of gauge how many of you are actually familiar with DigitalOcean and what we do. Okay, a good number of people, but just for the benefit of those who may not be, DigitalOcean is a cloud provider, infrastructure provider, kind of like some of the other ones you might be familiar with. We pride ourselves in providing a very simple user experience while still giving you the same powerful primitives underneath the hood. We sort of started, or the company was started about 5 years ago, back in 2012 really, and we've sort of grown quite a bit since then. I myself joined the company 4.5 years ago. When I joined the company early 2013, we were 5 people, and we had 2 data centers around the world, and I think we're probably in less than 1,000 servers. Today things are a little bit different. We actually just this past summer crossed our milestone for over 1 million customers, and we're now somewhere between 60 and 70 million virtual machines launched on our platform in that past 5 years. And then we are now we have available 12 data centers available across 3 different continents. So you have a lot of places to choose from. And actually, as of this morning, we launched our newest product, which is an object storage offering called Spaces. So if you're in the market for object storage, I would highly recommend you go check that out. With that out of the way, I kind of want to set some context here first. This journey, or the content kind of starts from back when I first had joined the company. The sort of the journey that we've been on for the past 4.5 years that I've been with the company is really what I kind of want to take some, reflect back on and share some learnings from. So very early on, when I first joined, we back in 2013, early 2013, we basically had 2 monoliths. And I think a lot of companies start this way. It's a pretty reasonable way to start. We had what we lovingly called the front end and the back end. That's not very creative, but it was enough to get the company going, and it provided us with the ability to provide a service to our customers. So that was great. A little bit later in that same year, we took the front end monolith and kind of split up the different responsibilities that it had. It had an API, it had like a public-facing website, it had an administrative component to it, and we just broke those out into separate monoliths of their own. Not much, about a year later, I should say, we started diving into the world of services. I think it gets talked about a lot these days, and rightfully so. But for us, it was only 3 years ago when we first started looking at services. We had grown to the point with our teams that it was actually quite difficult for everyone to collaborate on the code bases that we had. People were stepping on each other's toes, and so we started looking for a better way to start composing the software that we're writing. And so we started sort of figuring out some pilot projects where we could take apart like a logical piece of functionality and separate that out into a service and still maintain the same functionality for our customers. And so, we were doing a little bit of experimentation here and there. We split out a couple of small services and went that way. Then by early 2015, we had got enough confidence with the way we were doing services and managing services that we thought now was a good time to start, making everything into services. So all sort of future development from there on was actually, always spun out into a service, which it wasn't necessarily before. And rather than calling them microservices, which I know is sort of the common term nowadays, a lot of our services weren't necessarily microservices in that they might be a little bit larger. They might be composed of a couple different components. So I like to call them sort of right-sized services, because the size of the service doesn't really matter as long as it's doing logically sort of a single function or a single job. And so with that evolution around our architecture, at the same time we had an evolution or like a continuation of how we were doing operations. So when I first started, I like to think of the way we were handling and managing operations was as what is operations even? Even though this was sort of the business we were in, I like to think that we weren't quite as good at it as we should have been, but we've obviously upped our game a little bit since then. 2013, or later in the year, we started hiring folks who were specifically focused on enabling us to sort of operate the software at a much bigger scale. And so we started embedding these folks into the software engineering teams, which I guess now is now known as more like a DevOps style, where you have your developers and operations folks working together hand in hand in a single team. And that was actually starting to pay off some dividends. But then in 2014, we made a decision to actually establish a more centralized operations function, because one of the things we're noticing is that for our operations folks, they were almost entirely committed to just working on the code on the services for the teams, which is good. But the problem was that was coming at the cost of a lot of duplication in operational functions that we would need across all those services. So we sort of pulled back and created a centralized operations function that was then responsible for servicing those teams, but also at the same time building out some of the infrastructure that we would need to more efficiently operate all the software. That sort of went on for the course of 2014, but in sort of 2015, we decided to make some changes just because we were at a point where we could scale our software engineering teams a lot more quickly than we could scale our operations people. If you've ever been responsible for hiring out operations folks, I think you may be familiar with how difficult it can be sometimes to find really good talent in this space. And so what we decided is we would hand over more of the responsibility for operating the software that the teams were creating to the teams themselves. And the operations function that was sort of centralized would kind of let go of that responsibility, instead focus on building those primitives that were used across all of our software, and then acting as more of an advisory role where they would help the teams sort of figure out, okay, how should I actually be operating this software? And that was pretty successful. But what ended up then ultimately happening is that because we were so successful with that model, we decided that it would actually be better if we just sort of gave the entire ownership of operating software to the teams, and then establish sort of software teams who were responsible for building the operational functionality as well. So effectively, we turned those operators or the operations function into yet another software team, or a number of those software teams. And that is the model that we sort of have today. I think somewhere else it's being called total ownership. And I think that's in my mind, that's the best way to function. But that does mean that you need supporting functions that are responsible for providing software that then it gets leveraged across all of your software teams, because it's not realistic for all of your software teams to be doing everything from the ground up, it's challenging, let's just say. So those were sort of the two parallels that we had going on. A lot of growth that was happening, which then required for us to start decomposing the monoliths that we had, and in turn actually spin up a lot more teams and that had sort of similar requirements across the board. So that sort of the overarching trends that you could sort of pick from those two evolutions, I guess, is we were moving away from a centralized setup towards a more autonomous or independent setup where every team was sort of responsible for their own things, and then we were pulling things into smaller and smaller pieces. We were doing away with some of the sort of generalized. There was no general role, like you were responsible for operating software, period. Like everyone was sort of responsible for that, but the software that you're responsible for was very specialized for what your team was providing, whether that was internally supporting other teams or actually customer-facing functions. And then finally, the other thing, or the last thing we had was around moving from sort of very static, where we had a couple of teams and a couple of code bases, to a more dynamic where teams and code bases could sort of come and go pretty quickly. Teams maybe less so than code bases. We would spin out services very often, but that on the team side there was a little bit more stability. Now, when I was writing this talk, I was trying to come up with the term. We had sort of this one problem throughout this journey, which was for a lot of the operational stuff that we're doing, we had basically one tool that we were relying on. This was our configuration management. Our configuration management was responsible for a lot of stuff. You start from bootstrapping and provisioning all the way up to application deployment and configuration and service discovery and everything in between. And if any of you have experience with that, I'm sure you're familiar with some of the pain that brings because everything is so coupled. It was yet another monolith, and it wasn't really helping us get our job done, to be honest with you. So I called it blunt instrument syndrome. The actual word for it is golden hammer principle. So if all you have is a golden hammer or a hammer, everything looks like a problem that you should solve with that. Reality is that's not necessarily the best way to go about things. So we got to thinking a little bit about sort of looking around and thinking about what our options are. So we had really good experience with operating container-based CI infrastructure and for a better part of a year. And so we started thinking about, so how would we take the software that we write and deploy today and move it to a sort of a new paradigm? And so we started looking around what's being used in the industry, what some of the companies that have been very successful with their infrastructure and operations and are really well known for it were using. And so the sort of 5 things that really bubbled up at the top were Nomad, which had actually just been released a little earlier, a little before we started down this path in late 2015. So that was the first thing we looked at, or one of the things we looked at. We had Apache Aurora, which obviously Twitter had massive success with, and that was really interesting based on the Mesos project, or on top of the Mesos project. We were looking at Kubernetes that had just reached, I believe, the 1.0 release at the time, maybe 1.1. We looked at Marathon, which is, had a lot of the primitives that we were kind of looking for in that, and it was really designed in a way we thought would actually fit for our use case. And then, of course, Docker Swarm from the Docker folks I think it was on maybe its second rewrite at the time, or had just gone through a rewrite. So it was interesting, but a little bit, we're a little cautious. So, being that we're at HashiCorp, I think maybe you'd expect me to say we picked Nomad. Unfortunately, Nomad, like I said, had just been released. So while we really liked the ideas in Nomad, we ultimately weren't comfortable with the sort of maturity the point at which it was then. So we went with Kubernetes. Kubernetes gave us some really interesting things. So it had a really active community and growing ecosystem. It was designed to be sort of API first, driven with APIs. And so while it had a command line that you'd use, it would still talk to the same APIs. So we could actually wrap our existing tooling and build other things on top of that API to drive it. It was sort of first-class container, or in fact, at the time, the only way you could run workloads on there. So we kind of liked that, the first-class container support. And then finally, it was sort of what we would consider production grade, because we weren't the only ones who would be running it in production. It was important that we weren't the biggest user of whatever tool we were going to adopt, because that, yeah, like you said, it's not the optimal experience. We wanted to make sure that there had been people before us had battle tested it and seen ways it fails and actually learned, and we'd be able to learn from that. But I think it is important it's worth spending a little bit of time talking about why Kubernetes versus Nomad. The choice back then was fairly obvious, given that Nomad was really in its infancy. I think if we were to be faced with the same decision today, I think it would be a lot less obvious whether we should go with Nomad or Kubernetes, because I think Nomad has come a really long way in the past 2 years. So you know, it's not as clear to me today that we wouldn't necessarily go with Kubernetes, especially considering that Nomad is designed to run workloads that aren't necessarily containerized. And one of the things as part of this, we actually had to make an explicit decision that we would not support some of our other workloads that are running, that cannot be containerized or cannot run in a way, or could, but probably won't be containerized. So in that case, Nomad would have actually been an interesting alternative for us. Anyway, so at this point, many people, or sometimes I see people come to this point and they say, well, I have Kubernetes now. All my problems are solved. Now what? You know, we're done here. Great, end of talk. That's not necessarily true. I think this is just a small subset of the concerns that you might have as someone who's operating infrastructure in production. Kubernetes takes care of some of these, but by far not all of them. And if anybody ever tells you that it does, they're perhaps not being fully honest with you, or maybe they're not sort of thinking about it from the right perspective. So we obviously needed to augment Kubernetes with other things. Kubernetes was really there for the service orchestration, lifecycle management, some degree of configuration management for these applications, but there's a lot of other things on there that we still needed support for. So with that, we get to the first project that we use from the HashiCorp folks. So Console has been something we've had in our stack for a good couple of years now. I think we're just past 2 years. It was the first tool that we really adopted and brought in. And in fact, when we were first evaluating the replacement for runtime, we actually had just deployed Console before that, and sort of we had been focused on service discovery because we felt like that was a big problem we needed to solve. But then we sort of switched gears a little bit after some rethinking and came to the conclusion that runtime would actually be more beneficial or provide us more impact out of the gate. So, but still, Console was deployed and has been in our stack for a while. So to talk about the ways we use Console, so there's two main reasons I think why people have Console, service discovery and the key value storage. There are other things obviously, but these are the two that we've adopted. So service discovery, we have many forms of service discovery internally. In fact, I think we're up to 3, maybe 4. So the sort of traditional DNS-based, static DNS-based service discovery, we had that. That was one of the things we were looking to replace with Console. And then the other thing we had was more of a configuration management driven, let's say not exactly service discovery, but where service configuration management takes a look at the inventory it has, takes a look at the roles or the way these infrastructure is described, and then writes out config files for you. Not exactly scalable, not exactly quick, but it got the job done early on. So these were two things we're really looking to replace in many cases. And some of the specific instances of this, we had a lot of services that need to run at specific data centers that a given service needs to talk to. So when it's reaching out to Console, it wants to talk to the closest instance of that service running for the specific data center. It doesn't want to reach out to the other side of the world to talk to the thing that's doing the job in the data center it's located in. And then the other one that we've been using Console for, or the service discovery for, is actually monitoring. So when our services come up that aren't running in our sort of new runtime, they sometimes, or I should say often, they register themselves against Console so that then the sort of centralized monitoring infrastructure that we have can use the service discovery on Console to figure out which targets it now needs to monitor for, and it listens for that. So for that, we actually use Prometheus, and it has built-in Console service discovery support, and that's been phenomenal for us because it's very easy for somebody to spin up a service as long as they sort of adhere to the standards we have, which is have your metrics available in this port and this path Prometheus can just go and figure it out as soon as your service comes up and registers with console. So that's great. Really, really simple use case, but works beautifully. The other one, so KeyValue. A lot of our services have sort of dynamic configuration that determines behavior that they might do. So an example of this is actually the feature flags. So when a service comes up, maybe all of your feature flags are either not there or they're turned off. But as you sort of release some software, you may want to, when you deploy some software, you may not want to immediately make it available to all the customers, but you can sort of incrementally control that release by just talking to console and flipping the feature flag for a subset of your users or subset of services or subset of some other group. And that's been actually really helpful for us to do sort of more slower controlled rollouts of features, either directly customer facing or something that might be more internal and something you would never know that you interact with daily. But it allows us to sort of manage that very easily and be very, rather than having to pull things, console allows us to just listen and watch for changes, and that's really great. Sort of the other thing that a lot of our services use it for is as a actual backing store. So rather than talking to a traditional database, we kind of use it as just a general purpose key value store. And for that, it's been really good. An example of this is we have a service that lives at the edge of our sort of API or between our customers and us. And so when you talk to our API, it hits this routing service or proxy service. And what it does is it looks at the request you're making, and then it determines what are the routes that it knows and which sort of set of microservices it can route that to behind the scenes. And so that service itself actually has a version control of the routes stored inside of console, and that has been really good for us. And then finally, we actually use it for Vault. We felt like it was a good combination, and it has worked so far. It has worked really well for us. So pretty basic use cases again, but those have been working well for us. So I just wanted to kind of mention that. So next up, we come to Terraform. So Terraform is, as a cloud provider, it's kind of interesting that you use Terraform to orchestrate your own cloud. It's been one of those things where we've been fortunate to have been part of the Terraform project since day one, and so we have provided our customers a way to interact with our API with Terraform since the beginning. But more recently, we've actually started adopting Terraform through an internal provider to actually provision and manage our own internal infrastructure for some of our services. So the Upstream provider, like I mentioned, was created by HashiCorp when they first introduced Terraform. Our customers of all sizes use it for managing various sizes of workloads and configuring all the different pieces of their infrastructure together. If you are familiar with our service, you know that we don't have a sort of a resource manager type of service like a CloudFormation or Deployment Manager or Azure Resource Manager. Instead, a lot of our customers actually just rely on Terraform to do that work for them, and it works really well. The sort of more recent thing that we've been trying to really do and make sure we actually target is whenever we release a new product, we should make sure that Terraform support is there at launch, because it's really important and really key for our customers to be able to leverage that. That's a sort of a traditional, that has become the de facto way for people to manage their infrastructure. And so it's important that when we release software, it doesn't take 6 months for them to be able to consume that through Terraform or our API. We've been very fortunate that sometimes the community comes through before our engineering teams get around to it. And we really appreciate that. But it is increasingly, we're wanting to make sure that day one, when there's a release announcement, there's a Terraform support for it. Because that is how people drive infrastructure today, and that's good. The other thing, like I mentioned, we have an internal provider. So this started out as a fork of Terraform at one point, and then it kind of has evolved into a life of its own. But basically, the way we use it today is we have two main use cases. So one, like I mentioned, we use Kubernetes. But one of the things about that is we need to have for that to be useful, we need to have that cluster Kubernetes available everywhere. Turns out that's a lot to manage manually. And it turns out that Terraform itself is actually one of the best ways for us to do that. So we've gotten to the point where we have 1 to 2 clusters in every single one of our regions in production. So that's somewhere between 15 to 20 clusters. But then when we bring up a new data center, it has gotten to the point where we can bring up a new Kubernetes cluster in a matter of 10 to 15 minutes. And that's immediately available for our internal developers to use. So that's pretty great. And the other use case that I'm actually responsible for a little bit is we use it for managing our CI infrastructure. So it's one of those things where you don't know how much capacity you need in your CI infrastructure until people start using it. And then, what I wanted to do is make sure that it's really trivial for us to scale that up. You never hear about some team starting to use it and they'll throw a ton of work at it, and then you're like, well, now we need to scale it up. And what you don't want to be in is the situation where it takes forever for you to manually bootstrap and bring up nodes. But instead, all we do now is change a number and run Terraform apply, and we have a bunch more capacity. And that's actually allowed us to also add more clusters or more deployments of our CI infrastructure in a bunch of new places. So we have staging clusters and development clusters and things like that. Those can all be brought up with the same a single set of Terraform modules. So it's really easy. And then hopefully, as everyone else here probably uses, we also use Vault. Vault is the latest addition to our stack. It's one of the tools that has really changed the way that we manage the software that we have. It's like I mentioned, one of the things we have is all the software teams are more or less fully responsible for the stack that they operate on. And that does mean that they have leeway to control, decide how they want to manage their secrets or store their secrets or any of the other things that they might want to do. But what Vault has really given us is it has given our application security team the ability to provide a really first-class experience, a really compelling experience for how people should be managing their their secrets. And that's been one of the big reasons why we don't have a multitude of ways of managing secrets. Well, we do, but we are in the process of centralizing those. So the two things we use is the KeyValue secrets and the sort of PKI or certificates backend. And so, like I mentioned, Vault has sort of enabled our application teams to start centralizing and bringing in their secrets from different sort of encryption and management systems that we have across the stack. One of the things, when you get to the size where we are, one of the things you'll notice happening is that you'll have one of everything all over the place. And it's really difficult to then bring those things back together and sort of centralize things. So I think because of the user experience and the workflows that we've been able to provide with Vault, that has really enabled us to be then able to go around and be like, hey, here's this other tool, you should just use this and it'll make your life really easy. And by providing just libraries and functionality like that, we've been able to sort of start pulling back that sprawl and bring it back together into a single tool. The other thing we have is our infrastructure has been, we use it, like I said, we use our configuration management tool for literally everything, and including secrets management. That has always been a fairly painful process and kind of a challenge. So one of the things we've been able to do is sort of bring Vault and integrate that into the existing configuration management workflow and just have it drive those secrets there. So it's really easy for someone to just migrate from the old way to the new way without really doing anything other than changing a couple of lines of code. That's exactly the workflow we want. And then finally, I mentioned this because I thought that it's interesting that more recently the CI tool that we use, Concourse CI, actually added support for managing your credentials that you use in your pipelines through Vault. And what's interesting about that is it it makes it really seamless. As long as you store your credentials at known good paths, it's really easy for you to then consume those directly in your pipeline definitions. And this has been a big enabler because before we had, we would have encrypted credentials in like Git repositories and all sorts of GPG nonsense and fun stuff. And if you've played around with GPG, you probably know that it's not the best experience. And so what we've been able to do is actually just make it so people don't even think about how their credentials are managed. And that's huge. It really, I can't underscore enough how helpful that has been for our folks. And then we use the PKI backend. So on top of the Kubernetes-powered platform, we've built a control loop in there where you can, with one line of code, you can say, yes, I would like a certificate for this. And then what happens is that the automation that we have inside of, built on top of Kubernetes, it goes out, talks to Vault, it issues you a certificate, creates a secret out of that, which then gets automatically mounted alongside with your pod. And then we have some libraries which actually will look for those secrets and then allow you to automatically renew that, or rather, when the certificate gets renewed, it gets automatically pulled into the application, and you don't even notice. So before, people would have to manually go and issue these certificates and generate them and then upload them and do this whole dance that could take half a day at worst. And now they don't even think about it. All they do is say in one config line to say, yes, I would like a certificate, thank you. And that's important because for us, it's important that the services that we have internally talk to each other over HTTPS or TLS. We want to make sure that our infrastructure is secure, and the only way you can realistically do that is by building in automation that will pull in those secrets, pull in those certificates, and make it transparent or seamless so that your engineers aren't thinking about it. The more we can give our engineers tools to do the right thing easily, the more likely they're to do that. And Vault has really enabled us to do that in many cases, but especially with the certificates, because certificate management is not a lot of fun. But it also, one of the things it has allowed us to do is still maintain a workflow for our older systems that aren't necessarily making use of the automated certificate issuing and renewal. It still provides a reasonable workflow for the folks managing those systems, and we're increasing to make that easier for them so that they can just automatically issue certificates for the services running in the more traditional configuration management driven way. So that's it, really. Those are, at a high level, those are pretty, they're easy to talk about. Those tools are really easy to talk about. But I can't really stress how important and critical they have been for us to enable us to sort of give teams reasonable primitives, ways to manage their infrastructure and software and services without having to spend a lot of effort. So I want to kind of touch on a few lessons learned. And I would say these are more generally applicable to infrastructure in general, like regardless of whether you're talking about these tools or other tools. I think one of the things I wish we had done more often is start small. We have had some very ambitious projects rolling out a tool and then only learning, maybe halfway through the rollout that maybe it doesn't quite work for the scale that we hoped for. Or maybe we didn't configure it in a way that it does the right thing. So I encourage you to start small if you can. Just get a pilot, start off with one project, and then as your confidence grows from there, just increase the adoption and keep rolling. But get some early quick wins and prove out that the tool is actually doing the job you thought it would, and then go from there. If you're someone with existing infrastructure and you're looking to bring in a tool to replace an existing tool, what I would recommend you do first is you look at integrating rather than wholesale replacing. I've not seen wholesale replacements go really well. It's kind of like rewrites, like they don't tend to go that well. But if you slowly integrate, you put it alongside the existing tool and then you migrate things over slowly, that tends to work pretty well. And before you know it, you'll basically be at a point where everything's migrated from the old system to the new system, and you can just cut off the old system and you're done. But I really recommend sort of like integrating with the existing systems first and then working your way up from there. Understanding your failure modes is pretty key. A lot of these tools are infrastructure tools, which means that if they fail, the rest of everything else that's built on top of them will fail. So I can't stress this enough. We've certainly made the mistakes of where we didn't fully understand or appreciate the failure mode of one of these tools or some other tool. We rolled it out into production maybe, or staging, and it failed. And then we're like, well, that's too bad. Guess we're gonna go to the manual and figure out what's going on. So I would recommend just really spending some time to getting to know the tool first before you go fully into production, and actually having some documentation in place, or at least some pointers to like what to do when stuff goes bad. And then these projects move really quickly. The community here is fantastic. I'm surprised how often there's a new release. So a couple of things that we've learned from these tools and actually Kubernetes is if you're not investing in automation heavily, if you're not expecting to be upgrading every 2 weeks, you're going to be in a bad place very quickly. One of the examples we had is we were on a version of console that was really doing poor performance, but had we just invested in upgrade process, we would have been on the next version that actually fixed all those problems. But we were sort of having less than optimal performance for about a year because of that, since we hadn't invested in a good upgrade process. It was too manual, so no one wanted to do it. And then, getting involved in the community. I think the community is really what makes these tools what they are. Being part of the community could mean just reading the notes and seeing the conversations and sort of looking at the issues. If there's ever a time when you or your company needs a feature, the best way to get that feature done is by being and participating in the community. Just being aware of what's being worked on, what's on the roadmap, and then hopefully being in a position where you can help influence that or drive that. That's really key. We've certainly benefited from that in a number of cases, so I can't stress that enough, or the importance of that enough. Finally, what we've done is we've sort of picked and chosen these tools, but I think that today, looking at it today, if you have the opportunity, I think the whole experience is actually quite compelling. Like, one of the things I do think that these tools do well is they play very nicely together. I'm actually a little bit envious of how good the integration between Nomad, Console, and Vault is. I think that's actually really something that if you don't have to write that yourself, that's hugely valuable. So that's something that I would recommend for you to consider, is if you're in a place where you get to pick one of these tools, or if you're in a place where you can pick something, just look at like what are the workflows, what are the integration points, what are you likely going to need to do with that tool, and see which one of those tools does it best. Because sometimes there are community projects, but they may not always provide the same level experience as something that actually has a tight integration provided already out of the box. So those are sort of my lessons learned. And hopefully you got something out of this. I recognize it. I'm here between you and lunch, so I want to end it there. I want to be respectful of that. And so thank you all for coming and listening.